IPv6 shortcuts. And IPv6 is a very long thing to type out over and over again. In this MicroNugget, we'll take a look at some options to reduce the amount of typing that we have to do. Let's begin. Our objective in this MicroNugget is really simple. We want to take a look at some basic details regarding an IPv6 address and represent some methods we can use, you and I, to save typing while working with them. Let's start off with an IPv6 address in its raw form, and that's right here. It kind of looks like a microprint on a signature line of a check, but that's 128 bits in binary, on or off, and that is an IPv6 address. It's 128 bits in length. And just as an FYI, an IPv6 address has two basic parts. There's the network part, and there's a host part, sometimes called a host ID part. And the network part simply represents like the street. Everybody on the same street has that same street name. Everybody on the same network has the same network number. And then we have the host ID, which is unique. So everybody on your street has a unique house number. That's what the host ID is as well. It's a unique identifier for individual devices on that street. And the dividing line, this guy in blue right here, is made up by the mask. So if we have a 64-bit mask, it says this: the first 64 bits are the network, stops. And then the last 64 bits are being used for host addressing. So the good news right off the bat is we do not have to input IPv6 addresses based on binary. That would be silly. It's going to take a long time of typing. Instead, we're going to use something called hexadecimal. In hexadecimal, we simply convert 4 bits at a time into hex. That's a discussion for another day. The point I want to focus with you on is we can even put in less characters than that. Here's some basic rules regarding an IPv6 address and working with it. Each of these groupings is 16 bits. And there's colons separating every 16 bits. So the colons basically say, okay, this is the beginning or stopping point for 16 more bits. So we have 8 groups of 16 bits each for a total of 128 bits. That's how it boils down. And here's how we can save some time. If we have a situation where some of those bits have a leading 0 in hex, we don't have to put that there. See that 0 right there? We don't have to add it. And that's why it's been omitted right here. So DB8, the system says, oh, DB8, I get it. There should be 4 hex characters here. There's only 3. I will assume, says the system, that there's a leading 0 there. So we've saved ourselves 1 character. We also have that same thing happening back here. You'll notice that we have omitted the leading 0s and simply put the 1 right there. Same thing with this guy. There's 2 leading 0s that have been omitted, and it's just a 52. Now, check this guy out. I've got 2 groupings. That's 16 bits and 16 more bits, and they're all 0s. If we have a contiguous grouping of 0s, we can go ahead and use this shortcut right here. And here's how it works. The system says, I know there's supposed to be 8 groups of numbers. And what it will do, it'll count. It'll say, I've got 1, 2, 3, 4, 5, 6. It'll say, there should be 8. I see 6. That means this double colon must represent 2 groups of 0s, or 32 bits worth of 0s. And that's how it does it. One interesting note about this game, where we're using the colon back-to-back to represent a set of contiguous 0s, is that we can only use it once per IP address. Why is that? Well, let's imagine that instead of using a 0 here, we use colon, colon there, and colon, colon there. So the system says 1, 2, 3, 4, 5. It knows there's 3 more groups of 0s. Are there 2 here and 1 here, or is there 1 here and 2 here? Are you with me? It can't just guess for us. I guess it could, but it won't be taken as a valid configuration. So instead, we're just going to use the double colon 1 time, and that way the system can fill in the blanks for us. Just looking at these two, can you tell me which one you would prefer to type in? Now, some of you are saying, Keith, I don't want to type in either of those. We're using DNS for everything. And DNS is going to be huge just like it always has been. But from a raw configuration perspective, using the shortcut method is much, much more efficient. In fact, even if we put in an IPv6 address the long way, it's still going to end up in the config and be displayed with the implied shortcuts at the end of the day. As an example, let's configure a loopback interface on R1. We'll plug in the full address just as an exercise and then take a look at the results of what's in the running config to see the shortcut version of that same exact IP address. At the console of R1 at the command line interface, let's go into configuration mode and let's just create a new logical interface. We'll create loopback interface number 99 and we'll give it that IP address. The the longhand, 2001, 0db8, 000, and all the details. And we're going to use a /64 to represent that the first 64 bits represent the network address, and the last 64 bits represent the actual host address. Now, if we take a look at what the running config thinks about this, I'm going to do a show command, but I'm going to set up some conditions so it only shows us the lines that include the word global with a capital G and the number 2001. That'll allow us to focus on just the details I want to share with you, and that is this. If we put in this IPv6 address the long way, it ends up this. So here's our 2001 right here. There's our DB8, which dropped the leading 0. These 4 zeros it put as a single 0. It would have loved to do the double colon, but it said, hey, I've got the 2 groups of zeros over here. I'd be better off if I applied that over here. So the system made that decision for us on that one. Here's the 1, 2, 3, 4. Here's the 2 sets or 2 groupings of zeros represented by the colon. Here's the 52. We dropped the 2 leading zeros off that. And there's the 1, which we dropped the first leading 3 zeros off that. Also on this output, it's showing us that we have a 64-bit network. And if you'll notice the colon here, check that out. That represents that the rest of the string is all zeros. So we have 1, 2, 3, 4, and that represents the 4 last groupings are all zeros. And that's a common method for representing a network. We specify the network bits and we zero out all the bits that are going to be host bits. In this MicroNugget, we've focused on how we can shortcut or put in less characters to represent an IPv6 address, and this could save us a bunch of time when configuring and working with IPv6. I hope this has been informative for you, and I'd like to thank you for viewing.